Благодаря на всички. Сега да си включим лаптопа. Така, доколкото разбрах, нали се чуваме окей? Всичко наред? Супер. Доколкото разбрах, да, това е QR кода, който може да сканирате и би трябвало след това да имате възможност да задавате въпроси. Той сега би трябвало да може да задавате вече въпроси. След презентацията, надявам се да има време, ще поговорим за тях и да, дори да няма време, може да ме хванете отвън и да си поговорим. Аз така иначе доста обичам да разговарям на всякакви технични теми. Между другото, презентацията мисля да е вола на английски. Има ли смисъл или не знам? Okay. So, I'm going to share a few words about me. I've been full stack developer for more than 12 years now. I am a Google developer expert in web technologies and Angular, even though lately I'm not so much writing Angular, I'm more into Next.js. I've been a lecturer in Sofia University in the Faculty of Mathematics and Informatics for more than 9 years now. And yeah, actually when I was putting these slides, I realized how much time has passed since I started and how everything changed, especially now with AI. It's just crazy when I go back 10 years ago and how different things are. I'm a big fan of TypeScript, even though in the beginning, because I was, let's say, a hardcore JavaScript fan, I didn't enjoy it so much, but I had to start writing it only because in Angular 2 it was integrated inside the library. But anyways, I'm also very passionate about building scalable and performant applications, and yeah, I've been a lecturer. Pre-COVID, I used to do a lot of events. Lately, I haven't done so many events because yeah, I don't have so much free time, to be honest. I work a lot and I also have a small daughter and so on. So yeah, the people with kids know what I'm talking about. But yeah, I'm very happy to be here on this awesome conference. And the funny part is that, yeah, not the funny part, but something interesting about me is that in my free time, if I have like free time, spare time, I am a DJ. I mean, DJ is a strong word. I used to DJ before I went to university. When I went to university, I had to stop because I couldn't deal learning and also doing this thing in the nightclub. So yeah, I'm just doing it from time to time if I have free time. And one interesting thing that I remembered when I was doing the presentation is that I had like a talk on DEV.BG, like my first talk on DEV.BG in 2016 when I was talking about dependency injection in Angular. And yeah, it just blew my mind that it was almost 10 years ago. So yeah. Okay, so today I want to just set the expectations because I don't want to have disappointed people. So today we're going to talk about TypeScript, but not the TypeScript that you're used to. Like, TypeScript is a bit of a strange language because it's like a superset over JavaScript, and you are kind of writing JavaScript with these type annotations and so on. But yeah, today I'm mostly going to walk through a few things. We're going to be dealing with types, and if you are a fan of functional programming, probably this lecture is going to be interesting for you because we are going to use certain concepts from functional programming. And yeah, what are we going to do? First, we're going to start by seeing how using only the type system in TypeScript we can actually program. We're going to create simple arithmetics, so addition, subtraction, and so on. And after that, we're going to see a bit more complex topics. So I hope that it's going to be interesting and useful for you. The main idea is to spark your interest if you're not already familiar with those concepts. And yeah, some of the things that you're going to see, probably if you're seeing them for the first time, they're going to be a bit complex. But of course, I'll share the presentation, and also I have everything inside StackBlitz, so I can also share a link to the code base and you can test it out and play around with it. So let's jump back to TypeScript. So as I said, TypeScript, it helps us a lot by being able to create different structures and like define the different types of our objects and so on. And it's very useful when we want to be sure that our code is working correctly. It's like a real-time linter, type checker, and it provides us code safety, maintainability when we want to do certain refactorings, and also if new team members join, it allows us to have completion in order to understand, for example, what are the function arguments and so on. So in general, TypeScript is great. Like it improves performance a lot, and I've been using it for, I don't remember. It's a long time, probably since since Angular 2 came out. So it's a bunch of time. So this is like a simple TypeScript snippet that you might see somewhere. So we have some kind of an enum. We have a type that is called user. We define the structure of the user. We have like a function called can edit content, and we are checking to see if the user role is admin or editor. And yeah, based on this, you can either edit or not. That's pretty straightforward, right? And on the bottom, we create a user, and we stick this type annotation that it's going to be of this type user. And this restricts us from like playing around with different properties and changing the different types. So that's what TypeScript is all about. The first thing that we're going to do is we're going to focus on this part where we're creating actually the variable in JavaScript. And then we're going to focus on this part where we're creating the function. So what I want to do first is kind of maybe change your way of thinking when you're writing TypeScript, because TypeScript is, like, for me it's very strange, because you can write JavaScript in TypeScript and you can write TypeScript. It's a bit different when it comes to types. So let's say that we want to create a variable, I'll call it, but it's actually a type in TypeScript. We can actually do this by just replacing the const with type in front. And this produces a type that is called current user, and it has these properties. Okay, but in general, like if we are replacing the constant and we want to be creating variables, we also want to restrict those variables, like we are restricting, for example, the variables in JavaScript when we are doing the type annotation. So we would like to do something like this, right? Which is not going to work, because after all, this is TypeScript, so we cannot define the type of the type. And this is where generics come. So with generics, we can actually create functions, and these functions can provide structured output. So from runtime to type level, when we want to create some kind of a user and have it restricted to a certain shape, of course we can use the generic this way. It's really interesting, because now when we go back to the function can edit users, we can also do the same using generics. So if you want to say that, for example, our function is going to work on one argument, we're going to define this argument. Let's say it's going to be called t. And then we can use the extends keyword and say, okay, this variable, let's say that we're going to accept, is going to have this exact shape. Not exact, but we need to contain this row inside this variable that we're going to get. So in general, when we go to the type level, the extends keyword, we can think of it as the triple equals operator in JavaScript. Even though we're talking about types, so it's a little bit different, of course. But when we start thinking this way about the type system, it turns into a programming language. So the next thing that we can do is, because we know the structure of the T that is going to have this row, we can extract this row and we can check to see if this row extends admin or it extends user. So we can decide if we want to return true or false. And this is why I say that TypeScript is very unique, because we can write JavaScript with TypeScript on top, but when we want to have fun, we can just use the type system and write almost everything using types. So as I already mentioned, generics on type level, we can think of them as functions, because they accept some kind of input and they produce some kind of output. So the type level constructs, we saw how we can create variables. So variables in the type system, we can use the type. We saw how we can create functions. We can create functions using the generics. And we also saw how we can do flow control using conditional statements, usually the ternary operator. I think that there's no other way actually on the type level to do some kind of decisions based on certain types. So now we come to the interesting part, the iteration, because iteration is a bit strange when it comes to the type system. So the most common way of iterating over, like let's say some kind of a type, is using the key of operator. So what we are doing here is we are using a map type. This is how it's called. So we're creating a generic, and we say that this generic is going to be some kind of, let's say, an object. And inside this object, we want to define what the structure is going to be. And we say, I want to take every key of t, and then I want to get the value of t. So at the moment, we're not doing anything. So if we receive an object, we're pretty much outputting the same object. But just by modifying something, now we have something different. So now we say that if we take the variable user, automatically we are putting read-only to every property inside this variable. So we can also do conditional filtering using the same methodology. So what we can do is, of course, again, use the mapped object, but instead of just returning t of k, so the value, we can check to see if this value actually extends string. So is it a string? And if it's a string, we want to return it. And if we don't want to return it, we want to filter it, we can use the never keyword. The never keyword, pretty much, if we have it, it's just ignored. And this way, we can create, like we can filter out certain properties. What I want you to notice here is that we're doing something a bit different, because instead of just returning the map object, like the new object, we are doing some kind of transformation. So we are saying that we actually don't want to get the new object that was filtered, even though we can do that. The only purpose why I'm not doing it is to show you that we can also do some kind of transformations here. So we are saying we want to get all the different types. So let's say the values of our object. And this, when we have our variable user, we actually get a union of all the properties that are strings. So this is how we can actually filter certain things. And the next thing that is very important, how we can iterate, and it's actually done automatically by TypeScript, this is using union types. So whenever we have a union type, TypeScript automatically iterates over each element of this union and does something on it. In this specific case, what we're doing is we're uppercasing each individual element of this union. Another interesting thing, and something that I like to ask on interviews, because I've been doing a lot of interviews for senior TypeScript developers, is the infer keyword. And the infer keyword is something that is very unique. We can use it in one specific case, and this is within a conditional type. And what we are going to do is, let's imagine that we have some kind of promise. Usually the promise is some kind of container. This container holds a value. But again, we're talking only about types here. So what we want to do is extract the type of the value from a specific promise. How can we do that? So we can say that we're going to have a variable t, and then we're going to check, does this variable t extend a promise? And if it does, we want to use the infer keyword. The infer keyword, what it does is that if the value that we provided is a promise, it will take out from the content, the type, and we can do something with this specific type. So what we want to do is just return it if it's true. If it's not, then we'll just return the type that we got. Or we can just return never. So here we can decide what we actually want to do. And this way, yeah, if we have a promise that has a value, if we use unwrap promise, we'll just get the type inside the value. Of course, we're going to get to more interesting examples. But first, I want to go through the basics. Hopefully, you're understanding them, because after a while, we'll get a bit more complex examples. So here, this is something that is already built inside the TypeScript system. It's called parameters, but yeah, what it does is we can get the arguments of a specific function. And again, what we say is we have the variable t. If t extends a function, we use the rest operator in order to gather all the arguments of this function. And we use the infer keyword to assign those types into this args variable. And then we say, okay, we return the args. If it's not a function, we just return never, as I already mentioned. And yeah, this is the example of how it will look. So we'll get an array of string and boolean. And now we're getting to the interesting part, why we're talking about infer, because we are still not done with iteration. So another very common way in order to iterate inside the type system is using recursion. So let's think about, let's create a filter. So what we want to do is filter out certain properties, very similar to what we've done before that, but we are going to work with an array of strings. So we're going to say, we have a function called filter. This filter will accept one argument that is called t, and this argument is going to be an array of strings. Then, the second argument is going to be something that we would like to filter. And what we can do is say, okay, if t extends an array, then we want to infer, so we want to get the first element of the array. So we're going to say square brackets, infer head. The head is like the head of the array. And again, we can use the infer in order to get all the rest of the elements using the rest operator. And I think that now, if you followed everything until now, it's very easy. We're just going to say, okay, I want to check to see if the head extends this other variable that my function receives. And if it does, then we want to, again, call the filter function. And then we're just going to eliminate, we're going to remove this head because we want to filter it out. And we're going to provide the tail and also the value that we are filtering for. If it's not, then we just create a new array with the head. And also we call the filter with the spread operator. In all the other cases, we just leave, not the other cases, but the rest of, like the end case, we just leave an empty array in order for everything to get collected and yeah, for everything to work. And yeah, we have rows, different rows. We are filtering for admin, and we get all the rows that are not admin, pretty much. There are certain limitations, of course, when it comes to this, and probably you can figure out why there are limitations, because this is happening. You know, it's not like we're working with the TypeScript compiler that is running inside our IDE, and if we don't have certain limitations, even though those limitations, sometimes our IDEs freeze because yeah, it gets quite complex, like calculating everything. It's something strange. So let's see something a bit different, something fun and interesting in my opinion. So let's try, because like in TypeScript we already saw like creating variables and all the other stuff, like for example with flow control, how we can filter things and so on. But let's talk about arithmetics, because this is something that in TypeScript is not possible like in the type system. It's not possible out of the box to do like calculations, for example, to maybe add two numbers and so on. How do you do it? How do you do it in the TypeScript on type level? So to answer this, like the key here are arrays. So we're going to work with arrays. So we're going to define a function. It's very simple, that just returns the length of an array. So we just say t extends array of any stuff, and we just return the length of this t. That's simple. Next thing, this is something that is very interesting, and you need to understand it. How can we create an equals? For example, if we have two types, like let's say the type which is the number 1 and the type that is number 2, how can we check in compile, not compile time, but in def time that those two values are equal? Well, we can say, okay, if t extends s, so if t is equal to s, And if s is equal to t, then we can return true. Otherwise, we return false, right? It's kind of correct. It looks really correct. The thing is that it doesn't work with union types, because with union types, we have this iteration that is happening, and this is yeah, pretty much making this simple function not work. So we have to do something in order to prevent this type distribution. We need to wrap those individual elements inside arrays. So we're going to check if the array that contains one single element, which is t, extends the array with one single element s, and also the opposite. And this allows us to actually check if those two values are equal to each other. We're not going to be using this. I just put it here because I think that it's interesting when it comes to arithmetics, and also it's an important operation. So yeah. So next thing, we're going to do a range. We want to create a function that we provide, like, let's say, the number 10, and it produces this array from 0 to 10. How can we do that? Of course, we're going to use recursion. So we create a variable that's going to be a number, and then we create another variable that has a default value. This variable, like, this is the way that we can actually create our own variables inside our functions when it comes to the TypeScript type level functions. And yeah, we just set a default value that is an empty array. So we're going to use this array in order to collect some stuff inside. And when we reach some kind of a end, we're just going to return this array in some form. And we're going to say, okay, so if the length of R equals the number that we provided, the end of our range, of course, we're just going to return this collection that we created. Otherwise, we're going to do a recursion. So we're going to call build range with the number, and we're going to increase, of course, the array with one element, pretty much. And this element will be the size of the current R. And that's pretty much it. So why are we doing this? Like, I wanted to create this range in order to be able to create this limitation so our ID doesn't freeze. So I'm going to create this type called allowed depth that will allow me to select only particular numbers and not force TypeScript, the TypeScript compiler, just to throw errors. Because if we try, for example, to do like some of the operations that I'm going to show with big numbers, everything will fail because of those limits that we already saw on the previous slide. This provides us this array that, yeah, we already understand, but we don't need the array, we actually need the union of all types. So we just use the number with square brackets in order to extract all the different values that we can use. And now, let's create why did I jump so fast to the next slide? I'm not sure. Let me just go back. Okay. So the next thing that we're going to do is create a function that we're going to provide a number, and this number is going to be we're going to create an array based on this number. You're going to understand why we need an array. Just, yeah, be patient a bit. So we say, okay, we're going to get a number that should be from the allowed depths. And again, I create this accumulator that is going to be an empty array. This is, yeah, pretty straightforward now. I hope that you understand it. And we say, okay, if the n extends the length of what we want to achieve, then we just return it. Otherwise, we call number of array. And, yep, we spread what we've collected until now. And we just add one additional element, which is the type of unknown. It doesn't matter, like, what is the type that we're going to receive. What matters here in this array is the length. So we're going to be doing arithmetics using the length of our arrays. And the first thing that we're going to do is create the successor function. For example, if I provide the number 4 to successor, we expect to get the number 5, right? This should be pretty easy. So what we're going to do is we're going to create an array of this number we're going to create a new array, and of course we're just going to add the unknown to this array, and we're going to get the length of this array, right? This is the successor function. So now, and of course we want to limit, because otherwise we might get a number that it's bigger than the allowed ones. So we want to create this I forgot the word, sorry. It's intersection between the result of the length and the allowed depth. This will allow us to only receive a number that is from the allowed depth and not a number that can overflow and break everything. And now, what we can do is, use the successor. For example, if we call successor to 48, we'll receive 49. And if we call successor to 49, we'll just receive never, because it overflows the allowed depth. And now we can create addition. It's really easy with addition. We just need to merge two arrays. And probably we just need to get the length of those arrays. And now we can add two numbers. Of course, we limit the result again to the allowed depth. And now we can add numbers. We can add 3 and 2, and we will receive 5. Now we can do subtraction. So I'm just going to go a bit faster through those because I don't have so much time left. Of course, you can check them out later. The slides are going to be available. And you can check if they're correct or not, but they are, because I already checked them. And here's the subtraction. Again, what we are doing is this is an interesting thing, because like we are constructing an array of a certain number, and then we are saying, okay, if it extends another array, and then we use the spread operator over the number to array of the other value, and we infer the rest of the elements. So what we're really doing is subtracting arrays. That's the interesting part. So it really works. Of course, we can do multiplication. It's a bit complex, so I won't go through it. And we can also do stuff like creating is less than or equals to check to see if like certain type is equal or less to another, and also is less than, which we just invert those values. Again, I'm saying this not so much to, I understand that you won't understand absolutely everything that I'm showing. The main idea is to spark your interest and to sit down and maybe write a few of those functions. And I'm also at the end going to share some materials that you can watch, and yeah, I promise you it's going to be fun. And this is, pretty much the end. So we have also division and modulus, I think it was called. And yeah, we pretty much created simple arithmetics using TypeScript. It's mind-blowing in my opinion. But yeah, so it turns out that if we have no limitations over the recursion and also no limitations over the union, TypeScript type system is Turing complete. And it's true. Actually, not sure how many of you know that, but a guy sat down and spent a lot of time. He removed all of the limitations of the TypeScript compiler and created Doom. And this was 3 months ago. I felt like it's 1 year ago. But yeah, it's crazy, and you can check it out. Like, it's in GitHub, and you can also watch his videos. Actually, the Michigan TypeScript YouTube channel, if you are interested in such things, I've left a link at the end. You can check it out. They have some really interesting videos where they solve different tasks. They're more fun than the ones that we saw. So how does this help us being like developers? Because obviously, yeah, I mean, it's fun creating arithmetics. It's fun maybe creating Doom in TypeScript, even though I'm not sure who has so much time to sit down and do it, but obviously there are people. Well, it really doesn't. I mean, it's fun, and people do it just for the sake of it. But what it shows us is that actually TypeScript is super powerful. And just by learning these concepts that we went through, like some of them, maybe I've missed something. And there's a few other things that I can show, and I will show. We can yeah, we can create some really powerful libraries and tools. And yeah, usually like, because when I worked on a lot of projects, and very often you need to create some kind of utility functions or helper functions or some kind of transformers and so on. And people that are kind of scared or they're not so familiar with the TypeScript type system, often they just use a lot of any's, and yeah, we are not type safe, let's say. And I ask you, don't be afraid, just try it out. There should be a balance between what you should, let's say, type and what you should not, because I often fall into this case where I try to type some kind of a utility function and I want everything to be typed, and I lose a whole day of just working with types instead of focusing on creating the functionality. And this is a problem because the customers and the users of your applications, they don't care about the types, you know. Types are for us, the developers. So yeah, you just need to find the limit, and when you see that something is not working out, maybe figure out how you can break it into smaller pieces or change it a little bit in order to maybe type it. And yeah. But what? Why am I in general talking about type level TypeScript? Yeah, I think it's 5 years ago, I created this library. It's not, of course, as you see, very widely used, but I used it in probably all of the Angular projects that I've worked on, because I was using NGRX. Are there any Angular people here? 1, 2? Okay, there are a few. So with NGRX, it's like it's very simple. It's like a Redux pattern, and yeah, you have the store. You also but you also use ArcGIS. And as a really big fan of functional programming, of course, I'm a big fan of ArcGIS, and I'm really sad that lately I cannot use it so much because, yeah, I'm mostly working on next projects. But yeah, I created this library that should be really a utility function that allows me to create this kind of I call them bundles. So yeah, today I'm just going to go through a couple of slides and we're going to create something similar. And my idea here is to actually show you that the things that we learned until now are useful, and yeah, I mean, you can just utilize them in your day work. So the idea of these bundles is, yeah, I'll just wait a little bit to explain. So let's start fresh. So when it comes to Redux, what we have is we're dispatching actions, right? And usually we have this action creator. So if you use NGRX, you're going to find something very similar to what I'm showing you here. We have like a factory function that allows us to create events. And using the props, we can just define what type of payload we're going to have in this action. And then, yeah, pretty much we can see that we have type typization for the type of the action. And also, whenever we call the function, we have type typization for the payload. So let's see how we can create this thing. And later, we are going to see how we can extend this example by creating those bundles that are going to be for asynchronous actions. So creating the event is pretty easy, but we use this props function. This is only a utility function. I didn't invent it. I pretty much got this logic from NGRX itself. I like to read the source code from time to time of libraries in order to see how they created things. And it only exists to support us, the developers, to have like a better API, because I'm not sure how many of you try to create a library, but it's extremely hard to create a nice API, a nice way of using your library, and also for it to be maintainable. So often people who write libraries, they create these utility functions in order to make things a bit more clean, let's say. And what it does, it just receives one argument t, and it just returns it pretty much. And we use it as so. So the interesting part is creating the event. So the event is going to accept one argument that is going to be a string, and the other argument that is going to be the R, which is the props function, the result of the props function. And pretty much this is it. So inside the function, we're going to create like the so-called creator, and we're going to define that this creator is going to get a payload. We check if this R argument that we received from the props function is void, meaning that it's provided or not. So if we have not provided the props function to the create event, it's going to be automatically void, because we signed it on line 7 at the end. We put a default value for it to be void. And if it's void, we just want to return void for payload. So our action does not accept any payload. If it's not void, then we just return the type. And again, for what we are going to return from this creator, we check, okay, is R void? And if it's void, we only return the type, which is the string that we provided for our action. If it's not void, then we create a payload inside this action, and we implement the logic. As you see, like on, what is it, line 11 at the end, I put as any, and often you'll see me adding these as any's inside the bodies of the functions, because usually with utility functions, you should not spend so much time into defining. Of course, it depends on the complexity, but if it's a simple one, you should not spend so much time into defining the typization inside the function, because I just don't want to waste time. The important thing for me is this function, when people use it, to be typed, to be typed, so we can understand what actually it's returning. And yeah, pretty much that's it. We have the create event function. So now let's create our asynchronous bundle factory. So when it comes to asynchronous events, we have a few things that happen. So we have the trigger, so we trigger the action, and we have certain outcomes, right? So whenever we are working with, let's say, HTTP calls, we trigger the load, let's say, users, and we have a few other actions that we also need. We need the success for this action. We also need the failure for this action. And because it's an asynchronous operation, sometimes we just want to cancel it. So we want to create a cancel action. And the whole idea of this library that I created is exactly this. So whenever I want to create actions, instead of creating one single event and having this boilerplate copy and pasting like most of the people do, I just, or at least they used to do it, I just use these bundles and I generate actions for everything that I want. And pretty much the code will look like this. And then we're going to get these bundles, and we're going to provide to another function that automatically will connect everything to, let's say, the Redux store. And instead of me doing some extra work, I'm just going to use this object in the site. It's called async bundles, and I'm going to do all the control from here. So I can dispatch events, I'll be able to listen for events, I'll be able to create events. So let's create some helpers. We're going to create a helper called async bundle. We're going to get the type, the string of the action, and of course we're going to get the different props for the different cases, right? Here we're going to use template literals inside the map type key, and we're going to say, okay, I'm going to get the key that is inside. So for each, no, actually here we're creating a new type, and we're just getting the string that is provided for the given action, and we're just creating a new, how should I say, new property on this type object. And what we're doing is we're capitalizing the first letter. So for example, if I created, let's say, if I use create action with load users, here I'm just going to get a property called trigger load users, and it's going to be camel case. So by using type literals inside the map types, you can change the variable names, and you can also put static parts as well. And what we'll do is just, it will return the return type of the create event. We do the same with the success. So for example, here the type of my action will be load users success, camel case. We do the same for the failure, so it will be load users failure, and of course cancel load users. And as you see, we use the ampersand, it was called, in order to connect everything into one type. And this way, we create the new object that contains all of those values. Now we can get to the implementation in JavaScript. It's not very crazy, like in JavaScript it's easy. And yeah, we have this thing called create bundle. So now, let's jump, because we don't have so much time, into creating this other function. So the other function will get an array of those async bundles, and it's going to create all those different communication methods that I can use for all of the bundles that I provided. Okay? And yeah, as I said, we're going to have dispatchers. So using the dispatch property, we're going to be able to dispatch all the different events directly to the store or wherever they're going. With listen, we're going to be able to listen for all the different events. Like in Eric.js, as I mentioned, we're using observables, so we can like subscribe to different events from here as well. And also we can use the action creators in order to create actions if they're needed. Okay, so I'm just defining the observable type here because yeah, I have it in the example that I'll share later, because yeah, I have not imported Eric.js or anything, but yeah, we are going to just define it for simplicity. And we're going to create this very important type that is called union to intersection. So the idea is, if we have a union type, to create the intersection of the union. So we say something very interesting here. We define the argument u, and we say that the argument u is going to extend any. This is always going to be true, right? This is why TypeScript type system is a bit crazy. So we can do something like this. U extends any. In this case, I'm just going to create a new function, and this u argument is going to be actually the arguments of this new function. And then I say, otherwise, yeah, otherwise it will never happen. And then I'm going to try and get the result of this. And I'm going to say, okay, if this extends a function, and I know that it extends a function because I created this function, I want to infer a new value, which is I. And if this is true, I want to return I. Otherwise, I'll just return never. And what this does is that, yeah, we have a union, and it creates an intersection out of the types. And this is only because this is how TypeScript works, pretty much. It just works out of the box. And this is something that you also have to remember and keep it in mind when you're working with the type system. That, yeah, I mean, this is how TypeScript works. In order to be able to kind of, because you're putting certain restrictions, in order for those restrictions to be complete, yeah, let's say, TypeScript just distributes them. Not distributes them, but just creates this intersection type. Okay, now a few easy helpers. Element of, that allows us to provide an array and get the union of the elements. We're going to use this for iteration. And now we're going to define the listeners. So these listeners are the observables that we can listen to. And we say, again, we have this t. We're going to iterate over the keys of this t. And for each key, we're just going to put this $sign on the back, which is a convention when we're using observables, in order to mark that this property is an observable. And then we just say observable. And if this is a function, yeah, we just return the type, like the creator of the function, pretty much. Otherwise, we check to see if, otherwise if it's not, we just return this empty function. I'm just going to quickly go through the other ones because I don't have so much time. But yeah, this voidify, it's really interesting. I just am iterating over each function, and if it returns something, I'm just saying that it will return void from now on. Because like for the dispatchers, I don't need to return anything. And yeah, create asynchronous bundles. We get the array pretty much, and yep, we say that we are going to return a new type with create, dispatch, and listen, and we're going to use this union iteration. So we're going to get all the elements of this list that we created, and we're just going to transform them with the specific functions that we just defined. And we don't even need to care about the implementation because we are we're creating everything on type level. And yeah, pretty much that's all. So what we created is we have these create actions that have typization, which is great. We also have the dispatchers. As you see, it's returning void, but also it accepts the proper payload. And we also have the subscribe. And inside the subscribe, what we can do is also have types for the things that we're going to be working with. And that's pretty much it. I've spent so much time into creating this library 5 years ago, and it's funny how I can just fit it in a few slides and present it to you. Of course, it's a bit more complex when it comes to Angular, because there are certain concepts that you have to implement there as well. But in general, if you have those as a base, like those types that I showed you as a base, it will be super easy for you to actually create it. So I've shared a few links. So first is the YouTube channel, Michigan TypeScript, that you have to definitely check if you're interested in more in the TypeScript type system. And I also added a few other links for education. The rest of the links on the bottom, if you're using if you don't want to create certain utility types like the ones that I created, you can use TSDEF or TS Essentials or TS Toolbelt. There are all kinds of different libraries that provide you with such types out of the box. So you can also use them to learn. You can go through GitHub and examine the source code and see how they're doing those interesting types. And thanks very much for your attention, and hopefully this was interesting for you. Again, the idea is more to spark your interest and not so much for you to understand every single bit that I presented. And if you want, you can send me a message if you don't understand something, like maybe later on LinkedIn or whatever. But I'll be happy to check the questions if we have time. Do we have time or not exactly? Because I see that...
Може да свичим на български, не?
Може.
Добре. Няма да имаме много време за въпроси и отговори. Обаче, както Илия спомена, може да го хванете след лекцията, по време на почивката и да си поговорите с него.